Hey guys, this is going to be the recording of the Unit 4A review sheet. Those of you who have watched my videos know that Ms. Collins probably should not be doing videos very late, still at school. So hopefully I will not make any errors here. We're going to go ahead and start with our part 1 of similar polygons. We need to determine whether the following statements are true or false. So the first thing we're going to talk about is angle P being congruent to angle T. So what we want to do is we want to come over here to angle T, and we notice we have two arcs here. If we go to angle P, we're going to see two arcs as well. That automatically tells us that this is true. They are going to be congruent. We learned that angles in similar triangles are still congruent. Next, we're looking at segment PN. So right here, segment PN is included between angle N and O. That means it's the line between this angle and this angle, which clearly it's not. It's over here. The line or segment that is included between N and O would be the angles N and O. So this is false. Number 3 is saying that angle R is included between segment TR and segment SR. And this is going to be true. And a good way you could figure that out is you can see that both of these segments have that letter R in it. Next, we want to say that there is a ratio of segment OP right here to segment ST. And this is going to be true, and let me explain why. Segment OP, the length of OP, it goes from the one arc angle to the two arc angle. So it's going to correspond and have the same ratio as the side on the other triangle that goes from the one arc angle to the two arc angle. So that's how it's a really good way to figure out where our corresponding sides are. Next, we're going to take a look at the two quadrilaterals to the side, and we are going to answer the following questions. 5 says, what is the scale factor to create quadrilateral PQRS, which is here? So if we remember, our formula for scale factor is going to be new over olds. We are creating PQRS, so this is going to end up being our new figure, making this our old or our original figure. Okay? So what we need to do is we need to put a side from the new figure over a side from the old figure, but it has to be corresponding sides. So as we see here, we have a couple different numbers here. We've got 30 from CB and CB. These are going to be the two middle letters, which have to correspond with QR. And over here, we don't have a number for QR, so we can't use that 30. So the 25 is AB, the first two letters here, and the 45 is PQ, the first two letters here. So we're able to use these two numbers, the 25 and the 45, remembering that the new needs to go on top of the old. So we will have 45 over 25. We need to make sure that we simplify this. Both of these are divisible by 5. So when we divide 45 by 5, we get 9. 25 by 5, we'll get 5. So this will be our scale factor. Again, you need to go back and check. Ask yourself, when we went from our original figure to our new figure, did we get bigger or smaller? I see we got bigger. So we need to go look at our scale factor. Is our scale factor bigger than 1? And the answer is yes. It is an improper fraction, meaning it is bigger than 1. Okay? Next, we're going to take a look at, we want to find the measurement of angle R. So if we look up here in our name, R is going to be the third letter in the name. It will correspond with the third letter in the other quadrilateral's name of C, meaning angle R will be congruent to angle C. And angle C is 82 degrees, therefore angle R will also be 82 degrees. This part is not new. That we did this with our congruent triangles as well. All right. Next, we want to find the length of QR. Okay, so QR is going to be right here, and we've already established here QR, the middle two letters, we are going to be having that correspond with BC. So these two correspond. Similar figures, they are not congruent. I need you guys to make sure that you got that in your head, because I still see students telling me that, oh, well, the length of QR is 30. It is not. It got bigger. So we have a couple different ways that we can do this. We can either set up our proportion, which is what I'm going to do here. Okay, if I set up, I'm going to use these two sides, and I'm going to use QR as X, are missing. I'm going to set up 30 over X and set that equal to, now 30 came from the old figure and it's on top, so I need to make sure that I remain with that same figure on top, so I'm going to take the 25. Okay, so these two come from the same shape. These two correspond. So then I need to find the side that corresponds with 25, which we already established earlier was the 45. Now I will go through and I will cross multiply. When I cross multiply here, I'm going to get 25x. That will be equal to 30 times 45. This will give me 1,350. And then we divide both sides by 25. I'm hoping that is correct. I'm going to double check my calculator because I did this very, very late one day. 30 times the 45. Good. So when we divide by 25, we're going to come out with the answer of 54. The other way you can do this is, since we already have our scale factor right here, we can just simply multiply this by our scale factor. That's what the scale factor is. Okay, I know that in my notes and with my classes, we define the scale factor. It is a multiplier that determines how much bigger or smaller a figure will get. So all you have to do is multiply each side length by your scale factor to get the new one. So the other option is we can take that 30, multiply it by this scale factor of 9 over 5. And when we do that into our calculator, we will find out that we get 54 as well. Okay, so two different ways. I want to show you both ways, whichever is easiest for you. Now we're going to find the ratio of the scale factor, or sorry, the ratio of our perimeters. Okay, so with this, what we're going to do is all we need to do is use the scale factor. Okay, we don't have all four sides of these. Okay, we have two sides of each one, the corresponding sides, but I don't know what SR is. I don't know what PS is. DC, AD, I have no idea. But the good thing is, with your perimeters and your side lengths, they have the exact same scale factor. Technically, with ratios, it is the opposite of scale factor. Okay, so technically it would be, sorry, let me find out where I did my whiteout. A ratio would be the first to the second, so it would be 5 to 9, but we're allowing you guys to go ahead and keep with that new over old so that we don't get them all mixed up and start putting old over new. So we'll accept an answer of 9 to 5 as well. Okay? But I'll actually give you the perimeter. You just use that scale factor. All right. Number 9. Start bringing out all of my lovely colors here. Okay. Number 9, we need to find the values of x and y. So here we have our angle x. Let me figure out what colors I did on my answer key. Angle x over here. I'm going to put 3 arcs, okay, because this one has 1, this has 2. We need to figure out what the measurement is. Well, here I have 133 degrees. We know that angles are congruent. Here's my other 1 arc, so this is 133 degrees. And then this one will be 18 degrees, but the 2 arcs corresponds here and matches. So all we have to do to solve for x here is our triangle sum theorem. We can take both of these measurements, 133 plus the 18, and we get 151, and then we take the 180 and minus that 151, and we wind up with 29 degrees. So x will equal 29 degrees. Okay, this is something we have been doing for a very, very long time, triangle sum theorem. All right. What we have is a little bit new. This unit is finding a missing side. So here is y. Okay, so I need to figure out which side corresponds with y. The way we could do this, I mentioned this earlier with these arcs up here, is I take a look, and side y is between, you can either look at the arcs or the measurements, but it's between the 1 arc and the 3 arcs. So I'm going to come over here, and I've got my 1 arc here. This is 2 arcs. So I actually did not even mark that, but this would be the 3 arc. So between the 1 and the 3 arcs, between the 1 and the 3 arcs, the y corresponds with the 24. Then we have a choice. We get to choose whichever other side we want to. So first, to solve for y, I'm going to go ahead and set up my ratio of y over 24 and prepare to set that equal to, now I need to figure out what other side do I want to use. Well, it doesn't matter. So I like to pick the smaller sides, the smaller numbers, which will be 20. 20 is between the 1 arc and the 2 arc. So that means 20 will correspond with the side between the 1 arc and the 2 arc of 16. Okay, so then y came from the first triangle and it's on top. So I need to stay consistent and leave the 20 on top over here. And I know in my classes, well, we don't have names of these, but I would name it, triangle ABC on top, triangle DEF on bottom. But since the y was on top, the 20 is going to go on top. And then we'll place that over its corresponding side of 16. And then we'll go through and we'll cross multiply. Okay? So I'm going to take the y times 16. Give me, 16y. We will set that equal to 24 times 20. Well, 24 times 2 is 48, and then add on that 0, 480. Divide by 16. Y will equal 30. Okay. Number 10, we're going to do the same thing, but this time we're looking for both sides. And we're not looking for angles on this one, okay? So we could take a look at our different corresponding sides. Now, I have 4 different colors, so I'm going to label all 4 of my corresponding sides with different colors. The easiest one to find here is going to be 12. 12 is between the 1 arc and the 2 arc here, okay? So that's going to correspond with the 1 arc and the 2 arc over here. All right, notice the direction that they go. All right, so then I'm going to go from the 1 arc straight up. That will correspond with over here the 1 arc straight up. Next, I'm going to go to the 2 arc straight up. It will correspond with the 2 arc angle straight up, leaving us with our last and 4th side automatically corresponding. Okay? X is over here, so its corresponding side is with 14. So I'm going to do 14 over X. I will set that equal to, and I get to choose over here. Do I want the 12 and the 18, or do I want the 16 and 24? I almost went this way, okay, but we've got a y over here. So again, I like to choose the smaller side, so I'm going to stick with the 12 here. And since, again, 14 is on top and it came from this first figure, 12 needs to stay on top. You never want to cross multiply sides on the same shape, okay? And then the 12 corresponds with 18. We will do our cross multiplication. 12x is equal to 14 times 18 gives us 252, if I did my math correct the other night. Divide both sides by 12. And then we're going to be left with x equals 21. Okay? Now y. Y is going to be, wrong color there. Get my colors correct. It's that OCD in me. Y, to solve for y, is over here. so its corresponding side is 10. Now, it doesn't matter if I go y over 10 or 10 over y, as long as I stay consistent with the other ratio. Okay, so here I'm going to say 10 to y, and I'm going to set that equal to, and again, I get to choose whichever one I want to. I'm just going to go ahead and stick with the 10 was on top, so 12 goes on top, over the 18. Okay. I will then cross multiply and divide. A lot of this going on. 12y is going to equal 18 times 10. Well, 18 times 1 is 18. Then add on that 0. 180. When we divide both sides by 12, wind up with y will equal 15. You guys can hear me flipping pages here. All right, let's see how far I actually did on the key, the original key. Next, more similar figures. Now we've got more going on than just an x over here too, so we're going to have to distribute. All right, so we'll get some practice with that. Again, I've got my 4 sides. I can go ahead and find my corresponding sides between my 1 arc and my 2 arcs. 8 will correspond between 1 arc and 2 arc. 6. I'm going to have between my 2 arc and 3 arc. This will correspond with 2 arc and 3 arc. Then I will have my 1 arc and absolutely nothing correspond with my 1 arc and absolutely nothing. And then my leftover 3 arcs to no arcs. 3 arcs to no arcs. Okay, we got lucky here with these because the orientation, the position they're in is exactly the same. Okay, so first thing, let's solve for x. Okay, with x, we have here, sorry, I'm using the colors I used on my original answer key. I'm using my blue. Solve for x. I'm going to put the 2x minus 10 on top, and the side it corresponds with over here, x on bottom. I'm going to set that equal to, and I've got 2 different choices. Okay, these my pinks and my oranges. Okay, again, I like smaller numbers, so I'm going to do the 2x minus 10 from the first one was on top, so I need to leave the 8 on top, over 6. So when we start cross multiplying, here, remembering that the one loner right here by himself, the 6, is going to remain a loner outside of the parentheses. What is going on with x over here, when we have a coefficient other than 1 and or we're adding and subtracting, the 2x minus 10 needs to go on the inside. And I've discussed in my classes, some of us are liking the highlighting that minus 10, so we realize when we distribute, we're multiplying by negative 10. Okay. On the other side, we cross multiply, we get 8x. Okay. Now when we distribute, I'm going to grab another color. The 6 distribution means we're multiplying. The parentheses means distribution means to pass out to every single one of these. So we have to multiply the 6 times a 2x, and we're going to wind up with 12x. And then I distribute that 6 times, this is why I highlighted that minus, it is now a negative 10. So a 6 minus the negative 10 will give me negative 60. Put back in, now turns to a minus 60. Nothing happened yet over here. Okay, I'm going to run out of room here. You start writing a little bit smaller. So it's always suggested you move the smaller, the variable with the smaller coefficient. And I like how this is set up so you guys can see it's okay to get a 0 on one side of the equal sign. Okay, I'm going to subtract this 8x from both sides. I'll start writing a little bit smaller too. And I'm left with 0 on the right. That's fine, because watch what's going to happen. We're going to get a 4x minus 60 on the left. Now that 60 needs to be moved away from the 4x. and we do that by adding the 60 to both sides. We're going to get 4x equals, and now we don't have a 0. We moved the constant over, so now we're good. Last step, dividing by 4. And then our x will come out to 15. Again, assuming my late night math was correct. Okay, I'll draw this line to separate my y. Now here's my y. Looks like I don't have to distribute on this one. Yay! So I'm going to put 16 over y. Set that equal to, and again I'm just going to use my smaller sides here, 8 over 6. Now keep in mind, your teacher may have taught you, what I'm teaching you is going across figures. So my ratios go across the figures. Your teacher may have taught you going within the figures, saying you could do 16 over 8 is equal to y over 6. You can do it that way as well. It's all about what are you cross multiplying, okay? So with this cross multiplication, speaking of which, 8y will be equal to 16 times 6 should give you 96. Divide both sides by your 8. Simple one-step algebraic equation here. And I meant to do that on my color. Darn. Y equals 12. Okay. Next, number 12, same thing. Practice, practice, practice. We're going to get this down. The thing that has changed here now is we are going to see we have some congruent sides. Not with this one and this one, but within our one shape. Here, these two sides are going to be congruent. We see those tick marks. So we can label this 6. Okay? It's going to automatically correspond over here with our congruent sides, given this 4. Okay, also between the 1 and the 2 arcs, between the 1 and the 2 arcs, between the 1 and nothing, between the 1 and nothing. Okay? Now I'm going to take a look at x. X is between my 2 and 3 arcs, so I've got my 2 and 3 arcs right here. So when I set up my proportion, I'm going to do my 18 over x, and I'm going to set that equal to, I will take my 6, well, yeah, because they're both the same. I'll take my 6 over my 4. Okay? And again, real quick, cross multiplying, 6x is going to equal, and again guys, when we get to this part, please pause and go do the math on your own. I meant to mention that at the beginning. Do this math on your own and then resume and make sure you got the right answer, because if we don't know if we're not doing these on our own and then figuring out whether we've got it right or wrong, if we're getting it wrong, we need to be able to fix it. Okay, we need to be able to go back and look at, okay, where did I go wrong, so you don't continuously make those same mistakes. Okay, so equals 72. Divide by 6. Yeah, I didn't switch over to my purple. Oh well. X will equal 12. Right? Solving for y. Let's see, we'll do pink. Y is between my 3 arcs and my no arc. Between my 3 arcs and my no arcs. So here I'm going to set, again, pause it, set it up yourself, guys, and then press play and see if you did it correctly. Okay? Again, if your teacher taught you to do it within the shape, you still should be cross multiplying the exact same thing. Okay? Here I have y over 10. And I'm going to set that equal to that exact same 6 over 4. Press pause. Do the proportion problem by yourself and press play, please. It's only to help yourself. because this is where I stop telling you what I'm doing, because this is something we've been doing since the beginning of the year. Okay. Now we're going to go to our part 2 and look at specifically your similar triangles. We're going to determine if each pair of triangles is similar. If so, we want to not only write the similarity statement, which I know a lot of my students were getting confused on with the quiz, what the similarity statement actually is, but we also want to indicate which angle theorem, or sorry, which angle, sorry, I was looking at the 90-degree angle, which theorem, angle, side, or side was used, okay? So with number 13, first off the bat, what I see here is I see a 90-degree angle. So what that tells me is I already have congruent angles. So I have the A. And then I notice that creating that A are two sides with lengths on them both. So it's an included angle on both of these. So then what I need to do is go through and say, okay, well, if the corresponding sides are proportional, then I do have similar triangles. Okay? So we're going to take a look. I did this in my notes. So those of you who watched my notes on the blue, well, I know my foldable was blue, the Proving Similar Triangles foldable, we talked about the small side, medium side, and large side. When I'm dealing with side angle side, we only have a small and a large. So here, this is my small side on triangle ABC, and over here, 12 is the small triangle on EFD. And in a moment, you're going to notice why I did not say DEF. Okay? So looking at the ratio of the small side, which is what the S stands for, it doesn't matter which one you put on top. Okay? We're not doing scale factor. But whichever one goes on top, and on the first one, we need to keep on top. We need to stay consistent. So here I'm going to do 6 over 12 and simplify, and this will come out to 1/2. Then I'm going to take a look at my larger of the two sides, which is going to be the 7 and the 14. Again, 6 went on top, so 7 needs to stay on top. 7 over 14 simplifies to 1/2. So what I have here is, yay, my two sides, the two ratios were the same, so they are proportional. So now I have my side angle side. So here, we're going to write the similarity statement. Again, this is what your similarity statement needs to be. We are going to state here, let's see, what color did I not use? Triangle. First triangle does not matter which order you put the letters in. I'm going to go alphabetical. A, B, C. The similarity statement means I need to have that little similar symbol and say it's similar to the other triangle. Now the other triangle matters. Now, if you look at your 90-degree angle, B, that's going to have to stay, the 90-degree angle is going to have to stay in the middle. Now, whenever I said this, I said A to B, I went down the smaller side. Okay, you see how I went from A down the small side to get to the 90-degree angle? So here we need to do the same thing. Here's the small side, so E to F. So E will be first. Again, the 90-degree angle goes in the middle. And then we go down the longer side to get to that last letter. And that's why I did not call it triangle DEF. Okay? But it also wants to know which theorem was used. So we could say by the side, angle, side, and we could just put that for similarity. Okay? 14, we have 3 different sides. Okay? So again, it's very easy when I give you 3 sides of 2 different triangles. I give you all 3. It's very easy to tell which ones correspond. We're not given names. You go by the size of the number. Okay? For instance, this first triangle here, 9 is my smallest side. So when I look over here, I need to find the smallest side. Therefore, these 2 sides are going to correspond. So when I look at S for the small side, I'm going to put the 9 over the 3, which will simplify to 3. I'm going to go to my middle number. So the middle number between these three was the 18. It is going to correspond with the middle number here of 6. So M for medium or middle number. Okay, again, this one went on top, so we need to stay consistent. 18 over that 6. And this simplifies to 3 as well. So far, so good. Do not circle SSS and move on. Okay, we always have to check that last one. So then our largest side of 24 over 8, we lucked out here. They all three simplified to the same exact ratio of 3. We have 3 proportional sides. Okay, so then we can state our similarity statement. I'm going to write it here since I have room. Triangle. Now, again, the first one does not matter how you name it. Okay, my students know I'm very OCD and I stick with one thing. I get one, I stick with it. So I'm going to start here. The angle that's between the smallest and the largest side, and I'm going to say triangle J. I'm going to cruise down my small side to K, and then cruise down my middle side or my medium side to L. We're going to say it is similar to triangle. Again, I started the angle between my small and my large. So with the colors, it really helps see it. I'm going to start at the angle between my small and my large, I. So angle I. I cruise down my smaller side. So I'm going to cruise down my smaller side to H. And then I cruise down my middle side. So I'm going to cruise down my middle side here. And it'll be G. And we will say these are similar by, well, what did we do? We found 3 sides. So side, 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 similarity. Okay? Number 15. What I noticed with a bunch of quizzes is noting that we had an angle marked congruent somewhere, but then we forgot that there are a couple things that we need to keep an eye out for. With my classes, I informed you about the shared angle when you have the little triangle inside the big triangle, which I do believe we're going to see in a little bit. Okay, not with the similarity, but the other thing you've always been told to look out for, okay, since you learned about them, was these guys right here. Vertical angles. We have an angle. Now, do we have any side lengths? That was a pause to wait for your answer. There are no side lengths. So that is automatically going to rule out side angle side and side side side. But we still have to check. Yes, we have vertical angles here, but it doesn't say that another triangle over here is 80, or this one right here is 40 because it's vertical, therefore congruent, but this doesn't say anything about 80. We also don't want to look at these and automatically assume, okay, I got one, I don't have another pair. We have to go back to that triangle sum theorem. So I'm going to take the 60 degrees, I'm going to take the 40 degrees, and if you watched my video, I messed up on this one on the triangle similarity, or proving similar triangles. I don't know how I added those in correctly. This does come out to 100, and then I'm going to take that 180. I'm going to subtract the 100 to see what this angle measurement, angle M, is, and I'm going to find out that it should be 80 degrees. And now, once I find out that that third angle is 80 degrees, Mr. Bloom's looking at me weird all through the window. Now he's flicking rubber bands at my window. So he's trying to distract me to make this video longer. That's what he's doing. So here I've got 80 and 80, and I've got 40 and 40. The third angle theorem states that the third angle, if you have two angles that are congruent, bam, bam, your third angle is automatically congruent. But you don't need all of them, okay? This will be, so now that we know we have got at least two angles congruent, meaning all three are, this is going to be, these will be similar. Remember, your angles are congruent, your sides are not. So here, I'm going to go in alphabetical order on the first one. Triangle MNO, will be similar to triangle. Again, guys, this is the similarity statement I'm looking for. Now, M is at the 80 degrees, so is Q. Q is at the 80 degrees. That means M and Q correspond. So Q, N was at the 60, P is at the 60. P and O, because of vertical angles, they're going to correspond with each other. And we could say by angle, angle, similarity. Okay? So hopefully this got you guys, I gave you one of each so that you guys can kind of see it, see each one. I know in the notes we saw where they also were not similar, so keep an eye out for that. If your ratios here do not all come out the same, we don't have them similar. You also need to be super careful that you're setting the correct corresponding parts together. The last thing you need to do, and I saw this on the quiz, was put the small side over the large side, because then you're going to have the completely wrong ratio. Okay, so be super careful with those. All right, let's take a look now. Oh, we are still looking at, it says if the triangles are similar, find the values of x and y. So we're going to find our values of x and y. Now, 16 and 18 are different than what we've seen in our notes, sort of. I know that in my class with your angle-angle similarity, I showed you guys the small triangle inside the large triangle, and we actually separated the two. And I will be clicking on my calculator probably a lot in here because I don't actually have these worked out just yet. And I've lost my purple highlighter. There it is. Actually, let me do blue. So you need to see a smaller triangle inside the larger triangle. So what I'm going to do is I'm going to take one color, and I'm going to trace my smaller triangle here, and I'm going to draw him to the side. And I'm going to label what we have. We have a congruent angle down here, we have a 4 here, we have a y here, and we have an x at the bottom. Okay? Rewind and look again if you need to see exactly what I did. Traced it, redrew it, without any of this information. So now we see the small triangle. What I am going to do now is I'm going to take another color. I'm going to outline the big, large triangle on the outside. Okay? And I am going to then, I'm not going to make it that big. It really doesn't matter how big it is. Okay? But I'm going to redraw that one, noting that down here we have that congruent marking. The easy side to mark here is going to be the 6, right here. Now you need to be careful here. This side over here on the left is not 2. This side is the entire side. So this has to be the 4 plus the 2. So this side is going to be 6. Okay? Now we look at this side, and this whole side right here is the y and the 3 combined together. So since this y is not a number yet, we just put y plus 3. Okay? So now let's look at what we're going to do here. First, I'm going to solve for x. Okay? And for x, I've got x down here. All right? X is going to correspond with 6 over here because here's our angle. So I'm going to put x over 6. And then I can't include the y. We don't do 2 different variables in geometry right now, okay? So I've got the x over the 6. I'm going to set this equal to the 4 over the 6. All right? So now what we should see ended up happening is a lot of you are going to look at this and go, I already know what it is. But I'm going to show you the cross multiplication again, just in case. We have 6x equals 24. Divide. X will equal 4. Okay? So, if you looked over here, we saw here we had 6 and we had 6, meaning we actually had an isosceles triangle right where that congruent angle was. So up here, we should have had the same side as well. So these two ended up being congruent. Okay? Y is going to go a little bit differently here. Okay? So let's take a look. Over here, I'm going to set my y, this is squiggly line, y over the corresponding side. This is across from the angle that's marked congruent, so it's going to correspond right here with the side that's across from the congruent angle as well. So y over y plus 3. We will set that equal to, knowing that both of these are 4 and both of these are 6. Doesn't matter which side we use. Now, my blue triangle, my smaller one, was on top, so I need to keep it on top. So I'm going to have the 4 over the 6, and we'll cross multiply. Here I have y times 6. Again, especially with the distribution, guys, please pause. This is your own responsibility, okay? Pause it, see if you can do it on your own, especially if you're using pencil. If you mess up, whoops-a-daisy, it's all right, okay? You can erase. We will set this equal to, over here, we have the 4 on the outside, the y plus 3 on the inside. 6y has nothing going on with it, and then we need to come over here and distribute. 4 times y gives me 4y. And then 4 times a positive 3. This is where a lot of us mess up, and we're just going to put 3. It's not 3. It's 4 times 3 plus 12. Okay? I'm going to subtract that 4y. Oops, I did not mean to cross that out. Let me erase that so that I don't confuse you. Say 6y minus a 4y. We're left with 2y equals this 12. Divide, y will equal 6. Okay? Now, let's take a look at the next one. Okay? And we need to recognize our corresponding sides. Okay? With this one, we've got our vertical angles are going to be congruent, so we want to mark this. This is going to help us. Whenever I kept telling you the side between the 1 arc and 2 arc, that's where this helps us, okay? The side between the 1 arc and 2 arc, this 8, is going to correspond with the same side between the 1 arc and the 2 arc. That's why we want to mark those vertical angles. So 8 will correspond with y, and then my 1 arc to absolutely nothing. We'll go from my 1 arc to absolutely nothing here. Okay, so 10 will correspond with x. We do need to know the other one because we're going to have to use these two to help us. Our vertical angle to nothing and our vertical angle to nothing will correspond. Okay? So we're going to have to use these because both of the other two sides, corresponding sides, are missing a side. So I'll start off here when solving for my x. Okay, I'm going to start with the top triangle. I'm going to put 10 over x. I will set that equal to, now 10 is on the top triangle, 6 is on the top triangle, 6 over 12. Pause, solve. You don't need me to walk you through this, guys. We've done this enough. That's why I'm going to remain silent. And move fast. It's another reason you want to pause it. And x should come out to 20. That's just a kind of a heads up. I haven't keyed any of the rest of this out, so hopefully my math is correct. It's late. We know it happens. Next, let's solve for y. Okay? Here, I've got 8 over y. Setting that equal to, and I'm just going to use the same. I mean, you can use the 10 because you know what x is now. You can do 10 over 20 if you want. Okay? I'm going to do my 8 over y, and I'm going to go ahead and stick with the 6 over 12. Again, pause it, solve it, resume, because I'm going fast. Hopefully I did that correct. Did it all in my head. So forgive me if I did not. This goes in once with 3 left over. It should be 16. Now some students have started realizing and asking me, and this is fine. Once you realize that this is 20, the x is 20, to get from 10 to 20, your scale factor winds up being 2. So you multiply this times 2, 10 times 2 gets you 20, 6 times 2 gets you 12, 8 times 2 gets you that 16. So if you find out what the scale factor is, and I'm asking you for 2 different sides, and you already know, well, I multiplied 6 by 12 or by 2 to get to 12, you don't even need to do all of this. I have several students who have found that out. So okay, 6 times 2 is 12. So forget all this. 10 times 2 is 20, so x is 20. 8 times 2 is 16, so y is 16. Okay, you can also use your scale factor. On the next one, I'm going to separate my 2 triangles again. Okay, so you guys can see this. Here, I've got my smaller triangle. I'm going to go to the side. I'm going to draw him out just the best I can. Here's the congruent angle. This is 15. This was 12. And then take the bigger triangle. If I'm moving too fast, pause it while you color this in, guys. Okay, I love seeing these review sheets turned in with colors. Also tells me that you guys watched the video to help yourself out. I'm going to draw the other triangle. Here's my congruent angle. Oh, I forgot to mark the 10 right here. Get this 10 right here. Over here we have y. This whole side is x. Okay? And this whole side right here is the 15 plus the 6. Okay? And you'll get your 21. Hopefully. All right? So let's go ahead and solve for our x and solve for our y. Now going from 15 to 21 is not really an easy number to figure out what to multiply by. I do know that I've got some students who know how to work backwards to figure out what the scale factor is. That's fine. I trust them to do that, but I don't want to confuse you the day before the test, okay? So we're just going to go ahead and continue here. I've got 12 corresponding with x because these are both across from the congruent angle. So I will have 12 over x. I will set this equal to the 15 over 21. Pause it, solve for this. I honestly should not have to walk you through this, okay? Be quiet if you hear me typing. I want to make sure I get this correct. This late, I can't use mental math. Make sure I typed everything in correctly because I am getting a decimal. Yeah. Looks like we're going to get a decimal on this one. At least I am. Okay. Then we're going to solve for y. Okay. So 10 over y. They correspond. And I'm just going to keep with that 15 over 21. Do our cross multiplication and our division. We should come out with 14. Okay? All right. Now let's take a look at number 19. All right. Finding our corresponding sides. This is like the real world, the indirect measurement when we have the gorge and the canyon. Okay, these guys right here are going to correspond together. All right, and all this is this triangle has reflected, technically you'd say reflected over the x-axis and then reflected over the y-axis. And I know I showed my students that in class, so we wound up with these two corresponding and these two corresponding. And some students, again, you can look at this and already figure out what to do to the left triangle to get to the right triangle using your scale factor, and then going vice versa to get x, but I'm going to do obviously with our proportions. Okay, so I have x over 6, because those correspond, equal to my 4 over 8. Do the multiplication on your own. Pause. Solve it and then resume. Like I said, I'm going to do this fast. I'm not walking you through it. Okay? That's just for you to push play and make sure you got the right answer. Y. I'm going to have my 5 over y, and we're going to set that equal to, I'm going to use that same 4 over 8. Pause and solve it. Now, if you notice, the 4 and the 8 correspond. I'm going to explain this like I did number 17. To get from 4 to 8, you have to multiply it by 2. That's your scale factor. So if I want to find y really, really quickly, if I know I multiply 4 by 2 to get to its corresponding side, I can multiply 5 by that same 2 to get 10. This works the opposite direction, though. So I can't multiply 6 by 2 to get here. Now I'm going the other way. And so if I multiply to get from the left to the right, I'm going the opposite direction. I have to do the opposite operation. And instead of multiplying by 2, I'm going to divide by 2, getting me that 3. Okay? Guys, that doesn't make sense? Ignore it. Set up your proportions. More practice anyway. Okay? All right, let's see how blindly I can walk into this one. Proportionality theorems. In my class, I explained to you guys that a lot of these, sometimes you have your proportions staring directly at you. Okay? Here we have several ways of doing this. We can do this part. Now make sure you're looking at my fingers here. I told my class, I said, everybody look at the board, because I don't even have letters. This part to this part is equal to this part to this part. Okay? You can also do the x is to 18 as 33 is to 27. So many ways of setting this up. What I like about this is I can actually see my proportions set up on this problem. It works out so nicely like this. So we have 33 over x set equal to 27 over 18. Do our cross multiplication. I'm going to kind of carry it over here. 27x. I think this came out to like something incredibly big, like 594 or something like that. Oh, sorry. We divide both sides. Said I wasn't going to walk you through it, but I am anyway, aren't I? X will come out to 22. Okay. The next one, it's upside down. We can still look at it, but the problem is, I need you guys to understand, we have this part 15. We need to place it over something. This is not, we're between my finger and my pen, this is not 27. The entire thing is 27. We have the whole side of 27. We're removing that 15 from that 27. Okay, so when we remove that 15 from 27, all we're left with is 12. So now we have our 15 over 12 set equal to 20 over x. Pause it, solve it, resume. All right, let's take a look at 22. Still doing the same thing, solving with our proportionality. This is going to be our angle bisector, our triangle angle bisector. And we know that segment SU is an angle bisector because we see our congruent markings over here. So again, several different ways that you could set this up. If we rotate it this way, we learned that we could put this part to this part equal to this part to this part, or here to here is equal to here to here. So when I look at my picture, I like to look at it like this. It's looking right at me, okay? So I've got the 4y. See how much room I need for this one. I'll start up here. We've got, get all pretty here. I'm going to use, in my class I talked to you guys about, this is like the top of the tent or teepee. I'm going to use this one. So I'm going to have my 4y minus 2 over the 24. Okay. And then I'll use the ground part. Again, if we rotate this way, this is where it's sitting on the ground. There's the roof or the top of the tent or teepee. So I will set this equal to, now the 4y minus 2 came from this side over here, the angle bisector. So the 2y needs to stay on top over the 14. Okay? Pause. Distribute on your own, guys. You've got this, okay? When I cross multiply here, I'm going to go and bring it down over here. I'm going to have 48y. This will be set equal to this cross multiplication, 14 on the outside, 4y minus 2 on the inside. Again, some of us are we're really liking this highlighter. Remember that this is going to be a minus, okay, or multiplying by negative. So my distribution, let me break down my 48y real quick. 14 times a 4y, what did I do with my pen? There it is. 14 times a 4y is going to give me 56y. And then I've got my 14 times a negative 2, so I'll have a negative 28. All right? Again, we're going to see that zero out on one side for a little bit. I'm going to subtract 48y from both sides. Wind up with 0 on the left just for a little bit, okay, just for a little bit. And over here I will have 8y minus 28. But then whenever I add that 28 to both sides, let me carry this on over here, I wind up with 28 on the left, 8y on the right, and yes, this will come out to a decimal. My y is going to equal 3.5. Okay. Next, we'll look at number 23, our parallel lines and transversals. Okay, again, I've told my students, you've got your proportions staring right at you right here. This is equal to this. When you're not, when you're given each of these four parts. You can also do 12 over 15 is equal to x over 12.5. So here I'm going to do my x over 12. Set that equal to the 12.5 over 15. Pause it, guys. Go do the multiplication on your own. All right. The next one, I'm going to show you two different ways of doing this, okay? Because everything's proportional, Kind of goes back to that isosceles triangle problem we had. Where was that one guy? Did I lose him? Yeah, I think I lost him somewhere. My paperwork's here. Where we wound up having some congruent sides right here. Okay? What I want to show you guys is two different things. First, I'm going to show you just setting it up with our proportions like what we've done before. Okay? So here I'm going to set up the 2x minus 7 over the x plus 3. I will set that equal to this 5 over the other 5. All right? We'll go ahead and cross multiply. If you're choosing to do that, which I'm going to need the yellow here in a minute. We set that equal to, it's going to get kind of cramped here, sorry. Probably should have used a different color there. We will do our distribution from my awesome red marker here. 5 times a 2x, 10x. Then that 5 times a negative 7, negative 35. We set that equal to more distribution. Easy one here. 5 times x, 5x. Oh crap, really run out of room. 5 times a positive 3 plus 15. Okay? Sorry about that. So I'm going to subtract the 5x. Again, here, if you can read this, pause and go solve. So what, we got variables on both sides. We've been doing this. I'm going to show you a shortcut. Something that's a lot nicer than all this distribution junk going on. What we notice over here is all three of these are equal. Proportionally, that means all of these will have to be equal as well. I'm not saying this is equal to this, because that is not true. But with your proportionality, with your parallel lines, and your transversals here, the parallel lines and transversals, your theorem, if you notice this is all the same right here, that means all of these are the same. So what we can actually do, if 2x minus 7 is the same as x plus 3, because, well, hello, all of these are the same. What happens when two things are the same? We set them equal to each other. So the other way, if you notice something like this, shortcut, you could just do 2x minus 7 is equal to x plus 3. Let's work it out and see if Miss Collins is right. Subtract the x, left with 1x minus 7 equals 3. Add the 7. Well, look at that. I was right. Doesn't happen often, but, you know, hopefully I'm right on this one, right? I am teaching it to you. Now, number 25, okay? First thing we need to notice, so we do not lose points, is what do they want? Yes, guys, I get it. We're missing a part here. Yeah, we got to find it. But read your problem. Find CE. This is DE. I want to find this whole thing. So I've been telling my students, highlight what they want you to find, and if there's a picture, highlight that part as well. Okay? That way it stands out and it gives us more of an opportunity to not forget. But doing a lot of black ink over here. I'm going to make this a little bit colorful. Again, like I've taught my students, you've got your proportions staring at you. 4 over 2 is equal to 3 over x. So we have our 4 over 2 is equal to 3 over x. Go do this work on your own and then resume. You could pause it. Yes, you will get a decimal. So once we find x, that's great, but that's only part of what we were supposed to do. This is going to land you partial credit instead of full credit on a test, and we want that full credit because that full credit could have kept us from having to do retakes, okay? So CE, what we're actually looking for, we need to realize is going to be segment addition postulate, CD plus DE. So we substitute in. CD is 3 plus DE we found was 1.5. So the entire length of CE will be 4.5. That's our final answer. Okay? 26. Okay, 26. What we're doing here is we're missing a part right here, but again, looking at what we want to find, FD. This whole part, notice I did not go beyond the parallel lines, okay? So we're doing the exact same thing we just did. We're going to set up, I'm going to do 24 over x, and I'm going to set that equal to 36 over 27. Go ahead and solve this on your own, substitute it in. So when we find x is 18, we now need to go figure out the entire thing, the segment addition postulate. FD will be adding the length of FE plus the length of ED. Substitute in, FE is 24 plus that new 18 we just found. So the entire length of FE will wind up being 42. See, we're getting a lot of this repeating stuff. We've got our angle bisector, get AD. Segment AD is bisecting angle BAC. Because of these markings, find what? Find AB. So we're going to have to substitute in here. All right? So I am going to set this up like this. So I'm going to have my 3x minus 2 over the 2x. Set that equal to 12.5 over 10. Cross multiplying. I have 10, and then I have 3x minus 2. We set that equal to 2x times 12.5. It's going to give us 25x. And let's distribute. Apologize. 30x. Again, that 10 times 8 negative 2 is going to give me minus 20. And we're going to get to see that zeroing out on one side again. Make sure I'm still on the screen here. But next step, get rid of that constant. Add 20 to both sides. I got enough room here. 5x equals 20. X will equal 4. Partial credit, guys. Get your full credit. What was it I asked for? A, B. So over here, we could go through and say, okay, well, the length of AB right here was 3x minus 2. So we're going to use our substitution property and plug in what we found x was for. and the length of AB will be 10. All right? Almost there. Almost there. Let's talk about some indirect measurements here, guys. All right. Carson, he's going to be standing. So here's Carson standing. I'm not a good artist. He is going to be 3 feet from a lamppost, okay? And then here's my lamppost. The lamppost is going to be 12 feet tall. There's a light up here that's going to cast a shadow in front of Carson. So Carson's facing this direction, okay? He's 3 feet standing from the lamppost. So here's the lamppost height. Here's the lamppost, how far he is from the lamppost. This light is casting a shadow, okay? Carson is 6 feet tall. We want to know how long that shadow is, okay? So this is what we kind of have here. Not even kind of, it is what we have here. So again, whenever you draw your own indirect, like the shadows and whatnot, you have your proportions looking directly at you, okay? So we can do 6 over x is equal to 12 over 3. A lot of you guys are going to realize, how do I get from 6 to 12? Multiply by 2. So x multiplied by 2 would get 3. So we can go the other direction and divide, or do our proportions. We will get a decimal. His shadow is 1.5 feet long. Okay? So again, 6 times 2 is 12. 1.5 times 2 gives you that 3. Number 29, we have seen this before. We have the ratio, the measure of angles of a triangle, 10 to 15 to 5. What is the measure of the largest angle? So we're going to highlight that largest angle. And how do you figure out? I've talked with my class, how do you figure out which one's the largest angle? It's the largest number. Now be careful, these are not in numerical order. The largest number is at 15. Okay? So, we need to remember that this is simplified. Okay? It's a ratio simplified. We divided each one of the actual angle measurements by the same number to get here. So now we need to go the opposite direction and multiply it by the same number, our unknown, our variable of x. So when we take that 10x, we add it to the 15x. Where am I getting 10 and 15 from? Here, here. Plus the 5x. We're talking about angle measurements, 180 degrees. Okay? Combine your like terms. You're going to get 30x equals 180. Divide both sides by that 30. X is going to come out to 6. Not what I asked for. Largest angle. So we will now look at the largest angle was represented by that 15x. Excuse me. So we have the 15x. So we're going to substitute in 6 for that, and the largest angle will come out to 90 degrees. A little bit of review. Okay. Sum of exterior angles will always equal 360 degrees. These are exterior angles. So what we are going to do is we are going to add all of these exterior angles up. Doesn't matter what order. Let's go with here. We're going to take the 46 plus the 93 plus the 47 plus my 4x plus my 62 plus my 3x. And we set this all equal to that magic number of 360. We need to combine our like terms. I have a variable and coefficient here and one right here as well, totaling 7x. Get your calculator. Guys, pause this. Don't be lazy. Then we need to add up your 46 plus your 93 plus your 47 plus your 60. What was that, 2? Yeah. Okay? We add all of those up, we're going to wind up with 248, all set equal to 360. Subtract your 248. 7x will equal 112. And you know what to do from here. And all they wanted was x, so you're done. Now, I should have thought twice about number 31. And really see this quickly, but we are going to go ahead and remember. Right here, it should have stated that this was a rectangle. Okay, so this is going to be a rectangle. And we're seeing here that RT right here is for x, and SU right here, 32. Rectangle, your diagonals are congruent. So we set these equal to each other. One step to solve. Divide by 4. We find out that x will equal 8. Now, again, that's not what they wanted. That is partial credit, guys. We want RT, which is this whole thing, so we need to substitute in. So, if RT was 4x, substitute in 8 for x, RT will equal 32. And that's why I said, silly me. Right here. If these are congruent and I want to know what RT is, it's staring right there for us. But I want to make sure that we understood we need to remember things about our quadrilaterals, okay? Our diagonals are going to be congruent with our rectangles. All right? Last one. Yay, we've made it. Only over an hour. All right. Rectangle ABCD is similar to rectangle EFGH. The perimeter ABCD is going to be 48 centimeters. So ABCD is 48 centimeters. The perimeter of, let me see, I already used those two colors. Where's my blue? The perimeter of EFGH is 96 centimeters. We want to know the scale factor of ABCD to EFGH, meaning here that ABCD is our original starting with O, meaning the old one. Okay, we need to remember that scale factor, represented with the lowercase k, is new over old or original. And so we start with ABCD, that is our old one or our original one. And we're going to EFGH, which is our new. So, new of 96 over old of the 48. We simplify that out, it will actually divide evenly and give us our scale factor of 2. Congratulations, you made it through an hour-long video of Miss Collins. The longest video I think I've made in a while. I hope you guys do very, very well on the test. Please go back and rewatch parts if you need to. All right, good luck.